Today we're going to be reviewing solving equations. So for our first example, we have 2x plus 5 minus 4x minus 2 equals 13. So I'm going to start by drawing circles around my like terms to show. So 2x and negative 4x are like terms because they both have x. And as you see, I put my circle around the negative sign in front of 4x, so we want to make sure we do that. We take the sign that's in front of the term. And then we have 5 minus 2. 5 and minus 2 are like terms because they're both numbers, and they don't have a variable. So now I can go ahead and do 2x minus 4x, which is going to give me negative 2x, and 5 minus 2, which is going to give me negative 2x plus 3, and I bring down my 13. Now I have to get the variable alone on one side. So to do that, I can start by subtracting 3 from each side. That leaves me with negative 2x. This cancels out, and then 13 minus 3 is 10. So I have negative 2x equals 10. Lastly, I need to get the variable alone. So to do that, I can get rid of this number. To get the variable alone, I want to get rid of this number in front of the variable. So I'm going to divide both sides by negative 2. So 10 divided by negative 2 is going to give us negative 5, and negative 2 divided by negative 2, that cancels out to 1. So I have x is equal to negative 5. Okay. Next problem, solving this equation. As we can see, this has the distributive property in it. So to solve with the distributive property, we need to distribute our 5 to each number inside of the parenthesis. So I have 5 times 2x, and then 5 times negative 3. It's really important that we draw these arrows so we don't forget to multiply 5 by each number inside. So 5 times 2x is going to give me 10x, and then 5 times negative 3 is going to give me negative 15. Now I want to get the variable on one side of the equal sign and the numbers on the other. So to do that, I can ask myself, how can I move this negative 15 onto the other side? Well, the opposite of negative 15 is positive 15, so I can add 15 to both sides because that will cancel out. So then I'll have 10x is equal to 20. Now I need to get x alone, so to do that, I can divide both sides by 10. Because when I divide both sides by 10, this 10 will cancel out to 1, so I'll just have 1x is equal to 2. Okay. And if I'm going too fast, remember you guys can pause and rewind if you need to in order to get all of these copied down. Okay, next problem. So we have 6n plus 4 equals 4n plus 20. So again, I want to get my variables on one side of the equal sign and the numbers on the other side of the equal sign. So to do that, I'm going to start by drawing my line, and then I'm going to subtract 4n from each side. So I want to get this variable and this variable on the same side of the equal sign. So when I subtract 4n minus 4n, that's going to cancel out. And 6n minus 4n is 2n. Bring down my positive 4 and bring down my positive 20. So I have 2n plus 4 equals 20. Now I want to get the variable on one side and the numbers on the other. So to do that, I need to move this 4. So I can subtract 4 from both sides because 4 minus 4 is 0. So that cancels out that 4. So I have 2n is equal to 20 minus 4, which is 16. Now my last step, I want to get this n by itself on one side of the equal sign. And I want to get rid of this 2. So I can divide both sides by 2. That cancels out my 2 over here because 2 divided by 2 is 1. So I'm just left with n is equal to 16 divided by 2, which is 8.
I left your class, the class list.
Okay.
Okay, then thanks.
Last problem, 2 over 5x plus 5 equals to 9. So this problem has a fraction in it, as you can see. So before I touch the fraction, I want to get all the numbers on one side of the equal sign. So to do that, I can start by subtracting 5 from each side. So I'm going to subtract 5 from each side. This cancels out. 9 minus 5 is 4, so I'm left with 2 over 5x equals to 4. So to get this x alone, to isolate my variable, I can multiply both sides by the reciprocal. So remember, the reciprocal just means that I'm flipping the fraction upside down. So the reciprocal of 2 over 5 would be 5 over 2. And remember, the reason we multiply by the reciprocal is because by doing that, we're going to cancel out this fraction so that the x is alone. So 5 times 2 is 10, and 2 times 5 is 10. And 10 over 10 is just 1, so that's why it cancels out. And then on the side, I have to multiply by 5 over 2 also. 4 times 5 is 20, and then 2 times 1, we can imagine a 1 underneath the 4. 2 times 1 is just 2. Okay? So I have x is equal to 20 over 2. So my last step is to simplify. 20 over 2 gives us 10. X is equal to 10.
Now, please turn your guided notes over to the back side where it says no solution and infinite solutions. We've looked at solving a bunch of different types of equations. However, not every equation always has a solution. So let's look at some different examples here. The first example we're going to look at, 4n plus 4 equals 4n plus 20. Remember, when there are variables on both sides, we have to subtract the variables off from one side. So in this case, we're going to start by subtracting 4n, because I want this 4n to cancel out. But you might notice something that's going to happen. It's going to cancel out on both sides. Cancels out here. It's also going to cancel out on the other side. So all I'm left with is a 4 on this side and 20 on the other side. Now 4 can never equal 20. It doesn't matter what we put in for n because the n is gone. All I'm left with is something that cannot be true. When something cannot be true, we say no solution. So again, our variables canceled out. I was left with two numbers that didn't equal each other. Let's look now at example 2. We have 2n plus 2 plus 3n equals 5n plus 3 minus 1. Our first step is we're going to simplify on each side by combining our like terms. So on the left-hand side, we combined our 2n and the 3n to give us 5n. Our 2 stayed alone. On the right-hand side, we combined 3 and negative 1 to give us 2. So we ended up with 5n plus 2. Now we're ready to move forward. We're going to draw our line down the middle. And our next step is to get rid of the variables from one side. So I'm going to subtract 5n. But let's notice this again. I'm going to be subtracting 5n from both sides. My 5n is going to cancel again on both sides. So all I'm left with is a 2 on both sides. I end up with 2 equals 2. This is always true. 2 is always equal to 2. We say this is infinite solutions. What that means is it doesn't matter what we put in for n. It's always going to be true. I have 5n plus 2 and 5n plus 2. That's always true no matter what we put in for n, so we call it infinite solutions. One more type that we're going to look at, which sometimes is a little bit confusing. Okay, here's a case where I have variables on both sides. Okay, I'm going to draw my line down the middle on this problem here. I want to subtract the variables from one side. I'm going to subtract 2n. I think it's easier to subtract the smaller number so that I avoid negatives. Subtract 2n from both sides. It will cancel on the right-hand side. So now I'm left on my left-hand side with 8n, a minus 5 equals minus 5. Let's keep solving it as we ordinarily would. I need the 8n by itself. I need to get rid of minus 5, so I'm going to do the opposite. The opposite of minus 5 is adding 5. So I'm going to add 5 to both sides. Okay. My negative 5 and the 5 are going to cancel out. But they cancel out on both sides. This cancels out here. On this side, I have a negative 5 and a 5, which gives me 0. I end up with 8n equals to 0. Now don't be confused by this one. This does not mean it's no solution. No solution is when you have two numbers that don't equal each other. I still have my variable here. So I'm still going to move ahead like I normally would. I want to get the variable by itself. I'm going to divide through by 8. That will cancel on this side, so I have n is equal to 0 divided by 8. we can do this. We can do 0 divided by 8. 0 divided by any number is 0. So our answer here is n equals 0. Okay, shifting topics a little bit here, we are going to look at how to draw a graph of an equation. In our Do Not today, we looked at how to find an equation from a graph. Remember, we find the slope, the rise over the run, then we find the y-intercept. Our equation is y equals mx plus b. When we draw the graph, we're just going to work in reverse here. We're going to start with the equation y equals 2x minus 1, and we want to draw the graph. So working in reverse, we need to find the slope and the y-intercept from the equation and then draw those on the graph. Our slope in the equation is the number that goes in front of x. So our slope in this equation is 2. Our y-intercept is the term that we're adding on. Notice here, we are subtracting 1, so our y-intercept is a minus 1. When we graph, the first thing we do is find the y-intercept. So remember, start with the y-intercept. We want to find that on the graph. That is where our graph hits the y-axis. This is our y-axis here, so I want to look on my y-axis. I want to go to -1. It's going to be right here on my graph. So I am going to make a point here right at the y-intercept of -1. My next step is to make a slope of 2. Starting at this point that I drew, I need to have a slope of 2. Now I can make 2 into a fraction, make it 2 over 1. So 2 over 1, that means I need a rise of 2 and a run of 1. Okay? Rise 2, run 1. Let's look at how we can do this here. Okay? It's a little difficult to read here, but I'm rising 2 and I'm running 1. Okay? Over 1, up 2. I see here now I have my next point. Okay? I have my first point I got from the y-intercept, the next point I got from doing my rise and my run. Now that we have 2 points, we are ready to draw our line. We just draw a line that goes straight through these 2 points.